The topic of this lecture is short method of finding particular integral whenever qx is of this form e to the power alpha x into vx, where v is a function of x. We'll cover these points. F dy is equal to qx wherever qx is of this form, and two examples we'll cover in this lecture. So consider the general nth order linear equation of the form f dy is equal to qx, where these coefficients are constants for certain particular form of the non-homogeneous term qx, that is this one. In the above equation, there exists a shorter method of finding particular integral. So we'll see some particular form of qx and we'll see the corresponding method. So the task is explain the method of finding pi when qx is given as a e to the power alpha x vx, where alpha is a constant. So this is our task. The solution: consider an equation of the form f dy is equal to e to the power alpha x into vx, where what is alpha? Alpha is a constant and v is a function of x. Now we wish to find the particular integral. So by the shift formula, we know what we know by shift formula. When fd is operated on e to the power alpha x into vx, this becomes e to the power alpha x. This fd becomes fd plus alpha into vx. Now, what we'll do, fd plus alpha into vx, that we are going to write as a v1. So this whole expression will become v1. From this, we get when v is equal to 1 upon fd plus alpha into v1. Now, since as v is what? V is a function of x, so v1 will also be a function of x. On substituting the value of v in terms of v1 in equation number 1. Where is equation number 1? This is equation number 1. So we get on the left hand side fd, we'll write e to the power alpha x. In place of vx, we are going to write 1 upon fd plus alpha into v1. So we get this expression. And on the right hand side, all these things will become v1. So this v1 is over here. From this you can see, and e to the power alpha x is as it is, which is written over here. Now, when you operating both sides of this equation number 3 with 1 upon fd, what we'll get? We'll get 1 upon fd e to the power alpha x v1 x is equal to e to the power alpha x into 1 upon fd plus alpha v1x, where v1 is a function of x. Here, the left hand side, when we'll operate 1 upon fd, the left hand side is written over here on this way, and the right hand side is written over here. So because of this 1 upon fd, which is cancelled, and remaining term is written over here, and 1 upon fd when operated is written over here, where v1 is a function of x. So we get a formula that 1 upon fd e to the power alpha x into v1x can be written as e to the power alpha x 1 upon fd plus alpha into v1x, where v1 is a function of x. So we'll use this formula, which we have seen in last slide, to solve these types of questions. Find a particular integral of d square plus 1 x into e to the power x, e to the power 2x. That is the e to the power 2x into some expression involving x. So we can write this as 1 upon d square plus 1 x into e to the power 2x. E to the power 2x comes out. So, and this d becomes d plus 2 because the value of alpha is equal to 2 over here. So this becomes d plus 2 square plus 1 into x, and when we'll expand this, and this can be written as, again we'll write in the ascending power, so we'll take 1 by 5 common, so it will become 1 upon 1 plus 4 by 5 d plus d square by 5, that we can take combinedly in a one bracket, and all this will become the inverse of this. Inverse of this is this. And when we expand this using the formula which we have already seen, that whenever we have the terms like 1 plus x to the power minus 1, this can be expanded as a 1 minus x plus x square and so on. So using this formula, this is expanded and we get this expression. Now x is, we'll operate this on x, and recall what is d. D is nothing but d by dx. So using this we get this expression, and from this we get, so finally we get, on solving, we get this expression. So that is the particular integral in this case. Now let us take one more example. This is the example. Here we have to find the particular integral. The auxiliary equation is this, and the complementary function is this. We are interested in particular integral. So we'll write yp is equal to 1 upon d square plus 2 into this whole expression, that is the value of qx, and this will be separated first of all, and here e to the power 3x is out. You can see e to the power 3x is out. So e to the power 2x is out, and this expression we get, and when we expand this, we get this two expression. From this we get this expression. We'll write in ascending form, so it will be written as 11 plus 6d plus d square, and when we take the common, we take 11 common, we get 1 plus 6 by 11 d plus d square by 11. So this types of expression we'll get, and when we'll operate this, this expression will become this, and when x is operated, this is simply this 2, and here in place of cos 2x, here there is no problem. As we have seen in the last lectures, this d square can be replaced with minus 2 square. So here this is replaced with minus 2 square, and with the remaining expression we are again multiplying with 2d plus 1 in numerator and denominator. So in the denominator we get 1 upon 4d square minus 1, and numerator we are getting this. So again here we can put the value as a minus 2 square, and this will be operated later on. So when after operating this on this, we get this expression. On solving, we get finally this expression. So this is the answer. So this is the general way I have told to solve this. You can solve step by step, and you can find the answer very easily. So this will be the operator identity, 1 upon fd cos ax plus b. If you want to convert into e to the power ix form, so this becomes the real part. And if you want to convert the sine ax plus b, so this will be the imaginary part of this. And we can find the real and imaginary part, read as a real part and imaginary part of this respectively. So we can find this. So this example will be as same as I explained in last way. Sin x is converted into exponential form, and here we are, because the sin x is appearing, we will take the imaginary part. Sin x, in place of sin x we have written e to the power ix, and the remaining method is same as it is, and finally we get this expression. You can solve these questions very easily. There's no problem. Thank you very much.